Chapter 2, question 13, gives you a few abbreviations for units and asks you to give the complete name for them. So if you were to read these, if you were to see them and read them out loud, what would you say? So for the first one, now in each of these you see two letters. The second letter is going to tell you what type of part, what feature of reality you're describing: length, mass, space, time, or temperature. And then the first letter tells you how big you're thinking of. Is it a very small unit or is it a very big unit based on that metric unit? So for example, in the first part you see the second, we're going to look at the second letter first. So it's a capital L, and that capital L is the unit for space. It's a liter. So that's what we have right here. And so we know that that is going to be a liter. Okay, the first unit is a C, that first letter there. And so that prefix is a metric prefix. Now the metric prefixes are in this table, table 2.4, and you can see them here. The symbols for them are given in this column. And then the word that would correspond to them are in the prefix just to the left of it. So here we see a C, and so that's going to be centi. So this will be centi. So the way you'd read this unit, if you saw it, wouldn't be CL, it would be centiliter. Centiliter. And a centiliter is smaller than a liter, it's 1/100th of a liter. So it gives you a sense of size. Okay. Next, we'll look at the second letter first, and here you see that it is a G. Now, G, here it is on the left side, is a G. G is the unit for mass. It's standing for gram. And so we would write gram. The letter in front, the prefix letter, lowercase k. We'd go to table 2.4, look for that symbol. Look for that symbol, and here it is, lowercase k. That is the prefix for kilo. So we'd write kilo. And so kg is the symbol form of kilogram. A kilogram is a relatively big unit. It's 1,000 times larger than a gram. 1 kilogram is around 2.2 pounds. Okay, similar thing. Let's look at, for C, let's look at the second letter first. The second letter here is lowercase s, and lowercase s is time. That's the second. So this lowercase s here is standing for seconds. And the letter in front is the prefix. So that prefix, the lowercase m, to figure out what that is, we would want to go to table 2.4. We're going to go look at the symbols, go down until we find a lowercase m. Here it is. So that's the prefix for milli. And so we would write million here. So this unit would be read as not ms, but milliseconds. And a millisecond is a really small unit. It's around 1,000 times smaller than the base unit. So 1,000 times smaller than a second, 1,000th of a second. And notice in this table, they separate prefixes that make the base unit larger and prefixes that make the base unit smaller. So you can see that milli makes it smaller, specifically 1,000 times smaller. Okay, last but not least, D. Again, looking at the second letter first, we see a lowercase m. And the lowercase m is of those fundamental units that represent reality. We have the meter. And so here, that lowercase m will be, this lowercase m right here is going to be meter. The prefix, the uppercase letter, here's a capital G. So let's go to the table 2.4, and we're going to look for a capital G starting at the top. Here it is. So it is a giga. So we'll say, okay, giga. So this capital G, lowercase m, wouldn't be read GM. It would be read as gigameter. Gigameter. And notice that this increases the size of the unit. A gigameter is a billion times larger. A billion times larger than a meter. So 1 gigameter would be a billion meters. But in this is just getting you used to being able to read these abbreviated forms of the units. So you would read these as A, you would read as centiliter, B as kilogram, C as millisecond, and D as giga.